Hello everybody, welcome to the last part of this tutorial using Grasshopper and Runway. As we saw in the last part, what we did, we have this workspace with Postnet model working. So as you can see, it's tracking parts like facial landmarks, it's tracking basically my skeleton, so we're getting that information. And at the same time, what we did, we output this using the Runway ML component for Grasshopper to get the data from Runway. So pretty much what we did look like this, right? Where we have the Runway ML component with the input address for the server. We have a Boolean toggle. Basically, we set that we want this information, data, info, and errors, and we have this Boolean toggle that gets the data and creates this or give us this information. So what are we going to do today is we're going to use some C# and Python to actually clean this information and get the right information to get this as points. So we get the same points that we see in Runway inside Grasshopper. There are ways to do it. I will put this definition, these components that are right now not enabled. I will enable them so you can see what the output is. So this is my skeleton. So you see it's tracking parts of my body. It's okay, it works. Basically you can control geometry or whatever. Basically like don't pay attention to the head. I'm just getting like 3 points from that and doing whatever. But if you see, this looks like pretty clean, right? I'm just like making a circle. There's my head. Actually, I will, if I tilt my head so you can see that this is my nose and my ears. I have my hand up, right? It works. The problem with this is that to do all of this, I have a cluster that takes the JSON object and start like doing all this tedious like components. And I was thinking that okay, this works. I'm creating like everything. Even I'm using, as you can see here, like some C# to just parse data. But if we're doing this, which is already complicated and actually difficult to debug, why not using like coding? A small piece of code that we're going to use here. I will explain why we have C# Python and then C# again. It's kind of stupid, but it works, and actually will tell you why sometimes scripting is relevant. I'm doing this for academic purposes. I have here what I'm showing you, like the cluster with the information. So it's kind of complicated because you need to start like formatting the data, and in the end, after like using all these components, why not using just code? Again, like C#, a little bit of Python, and then something really stupid, but it works. C# again. There is a way to do this directly just by C#, but I will explain why I'm doing this kind of stupid thing to actually get the same results. So I will actually preview this off, and we're gonna get just the information here. As you can see, I'm lifting my hands. So let's work on it. So I'm just gonna copy where we finished last session. I'm gonna open a new document. We have this. Remember always to start Runway before starting your Runway, your Grasshopper component. We're going to use a lot of panels, so I'm just going to put a couple of those here so we don't have to copy and paste. So first one, I will start just like arranging this so you can have a sense on how data is being transformed. That's okay. At least we need 4 or 5 to see why are we doing this. So the first thing is just to realize that we have I have here this extra tab, I'm using a really nice and small program to actually get the JSON object information from Runway to debug it. So I will put the link in the description. You have to install it by doing File, Special Folders, Components folder, and your Components folder you will put this ghJson file. Remember to always unblock it. If it says here that it's blocked, you unblock it, restart Rhino, and it should appear here. So what this will do, you will parse this JSON string. That's what we're getting from Grasshopper, and the information that we're getting is this. It looks pretty similar to what we're getting here, right? But you see that it has a different format. It's like all the lines order, it's not like just one huge string. Basically, this is just like one string, continuous string. Now this is separated in lines, and that's a good first step. Now we need to get rid of these poses. So we will use the second component, JSON path. I will copy another panel here, and I will write $that poses. That is the path of the information that I want. And with this, I'm getting rid of this part, and I'm just getting only the information of the pose that I'm getting right now. I will save the file, of course. And I will put also this in the description link is Runway to Grasshopper Part 3. And after that, what we are going to do is, because this is separated in different lines, but it's still just like one data component. For example, if I try to graph this, it doesn't make nothing. It just adds one level to the data tree. So what I want to do is just go to sets, text split, and I will input this string. I will copy another panel, and here I'm just going to erase this and press enter. And with enter, what will happen is that we will split according to that enter, to that line change, to that new line, all the data that we have. And we see that the information gets transformed. Of course, that's the beauty of like Grasshopper, how basically the information flows and is being transformed. But we're full of this like weird type of information, right? We have square brackets, empty lines, that is not null data. It's just like something that says empty. We have the numbers, we have like 2 coordinates according to the points that we're getting. So we need to process this. And instead of doing what I showed you before, like a lot of components and it getting this like super messy, we can use C# and Python to actually interpret the data. So if we go to math, C# script, we zoom in, we are going to delete this guy. We are going to connect the R from split to the X. We are going to right click in the X, and we're going to say that this is a list. And we're going to force Grasshopper to say that this is a list of strings inside C#. So with this, we will get, if we double click, we'll get like the typical things that the C# script inside Grasshopper has. First, imports. This is something that probably in Mac I had a lot of problems making everything work because of the imports. So here we're using like system collections, generic to use array list and lists, some imports from Rhino and also from Grasshopper. And here we are going to write actually what is going on. And here we are going to implement some function. So the first thing that we need to notice is that our node, it has an output called A. And A is just an object. So we're going to say here, let's say that A equals to, let's create a method, a function, clean list, and it will take X, that is a list, as an argument. So this will say that whatever this function makes, it will be the output of A. oh, sorry, the output of I pressed backspace because of my Mac tendency of deleting stuff. So we need to create this function actually, and this function I'm gonna call it. It's gonna be a private list. We need to indicate the type of the return type of this function. It's a float, and we're gonna say like clean list. That's the name of our function, and this we will pass as an argument list string name x. So what we're doing here, we're creating this function that will return a list of numbers, decimal numbers, but it will take a list of strings of words to actually work. So first thing first, we need to create that list, the list that we will return. We create specifying the type. We will say result. We will call it result. That's fine. It's a new list of string. Oh, sorry, float. Float. I don't know why this changes. Float. Sorry about that. List string. It keeps changing what I'm writing. Okay, now we're good. So this is the list that will contain all of the result of our cleaning. So we will do now a for each loop. We will iterate through all the lists and perform something. So what we will do is do like for each string str in x, we will like iterate through each element of x. For each element of x, we will create a new string we'll call line, and we will basically replace all the tabulations. So if you see what we have here, we have not only like square brackets and empty stuff, we have a lot of like spaces and dirty stuff like tabulations that we want to get rid of, blank spaces and so on. So we will write this line and we will say str dot replace. And what are we going to replace? We're going to replace the tabulations, of course, the T. We're going to replace that blank spaces, and we're going to iterate through each character of line while line that index of what can we do here? Yeah, we do this. The tab is less or equal than 0 if it's a valid line. We will do line that replace tab, comma, and the space. Yeah, so with this we were getting rid of all this like tabulations and blank spaces. And now another cool thing that works in this case is that you see that we have many decimal numbers here, and also we have this annoying comma that separates both coordinates. We can do like different things in Grasshopper since we are here we're going to do one trick. Basically, we don't care if we lose even like 5 numbers of precision. So because we know that after processing this, we will get, let me show you the result first. Let's say that this is the end of our code. And we will say that result.add the content of line. But in order to do that, we need to convert the strings into numbers. Basically, line right now is just a word, so we want to convert this into line, and this will give us some errors. So finally, we need to say that return result. Basically, this function will return result, and it will be returned here. So if I click here, this is giving me an error. Let's create one panel that is easy to debug, the out, and it's giving me exactly what I wanted. So we will connect this immediately. It says that we cannot convert a string. We cannot implicitly convert a string to a float. And what we're doing, we're cleaning this, right? We're getting rid of all this square bracket and stuff that we don't want, and we're getting numbers. But actually, if you see again, this specific data here has a comma, and because it has that comma, it cannot be converted to a number. So we need to get rid of that comma to make it work. So we will add one more thing here, and also, yeah, we need to do a couple of things. We're not getting rid. We cannot do the conversion because we have square brackets and things like that. So we're going to say that after getting rid of the tabs and stuff, if line that length, basically the length of the string that we have in each list, it's bigger than three number. If it has more than 3 characters, we will add it to the list, right? We know that the square brackets, the lines have 1 or 2 characters, so we want to have more than 3, and it will add it to the list. But also, we want to perform some cleaning to that line to get rid of that comma. So we're going to get rid of the last character of that line. So for that, we can do line that remove line that length -1, comma 1. Basically, this will get rid of the last number of each line. And again, because in some cases we have like a lot of numbers, we don't care if we lose like a couple of precision decimals. And let's see how this works. It's still giving me an error. Length. Oh, I wrote length. Oh, yes, of course. Typos. Length. And one more. Line 69. Oh, of course, this is float. I was trying to create a new list of float by a new list of strings. And if this is okay, apparently it is. It's blocked my computer now. So after you press play and you press OK, you will see that now we're getting a list with just numbers. We're not getting, also you need to flatten the list after you press OK here in the C# component, and basically this code will clean your data, and it does a pretty good job. As you can see that we're getting just like exactly like 34 points of data. That is the output from Runway. So you can see here the evolution of our cleaning, right? It's good to see how the information is being transformed. Now, we're getting just one list. For some of you, it's really easy, just, I don't know, to add a bunch, again, of components to separate this in coordinates. Basically, what I want to have now is just like each, like separate list with X and Y coordinates. It's not necessary. You can, from here, you can, if you're proficient in Grasshopper, you can do pretty much whatever you want. Now that we have a list of data, we know that the first data point is like the X coordinate of the first point, the other one is the Y, the X, the Y, the X, the Y, the X, the Y. So we want to have like a bunch of lists with just X and Y information. We can do that in C#, but the problem is that we need to import link, I think is the name of the thing, to have like some functionality to have this and to do this in a couple of lines. So that is a little bit like complicated. I don't want to go there. So instead of that, I'm just going to use Python because it's really good to do this type of things. I'm just going to have Python script. If you go to math, script, Python, we're going to say that this is a list access and we are having float numbers as an input, and we're going to just do like a really small script. You see that is the syntax is different, but it's good to have like both scripting languages here. We will indicate first a number of elements per. Actually, that's not what this is what you're supposed to do. Hashtag number of elements per list. We'll say that n equals to 2. We want a list with 2 elements, and here we will use something that is called list comprehension. List comprehension to split list into multiple chunks of n elements. Beautiful. So we will say that A, not 1, A, which is the output of our component, will be equal to square brackets. We will say that X, how do we do this with list comprehension? I times and I plus 1. So we will iterate over each element of the list to do, sorry, this is n, the number, and we'll say that for I in range, basically for each element of the list, we'll do the length of X, that is our input, plus n minus 1. And so basically repeat this. This operation will do the splitting of the list into 2. Basically each list will have 2 elements, the n here, and repeat that for each, basically creating like each list. List comprehensions are a little bit difficult to understand, but I think this is correct. Let's test this. This should work. It's not giving me any error. I think this should work. Basically, we're using just like a loops inside, like loops in one line, to do what I want instead of using like, I don't know, like 5 or 10 nodes. It's not giving me any error. So if we, yes, so this is also like pretty interesting. What we're getting here as an output are Python lists. This is not something that Grasshopper can read, and that sucks. And again, the thing is like, can't we do everything in C#? Probably yes. It would take like more lines to actually do the things that we did with one line in Python, but now we're in the situation that we have IronPython list. How do we do this? We have to go back to Python and probably import grasshopper and to basically be able to create data trees. So basically we'll add more lines of code. We don't want that. There is like one really simple and nice solution to this. We will create another C# component and we will do right click list access. We will input this the A into the X and we will say that uppercase A equals to X. Give me an error. Oh, of course, this is not Python. I need the semicolon. And C#, because C# works with Python lists, automatically converts. This is again kind of stupid, but it works. Converts the data. Sorry, this is a list of floats, doubles in this case. Oh, we have an error, so let me. Sorry, this is not list access, this is item access. This should be just system object. Yes, sorry, my mistake. We just need to leave this by default. Just double click and write this because we're not. Yeah. So as you can see, finally, after all this transformation, we're getting our data formatted. We have like 1, 2, 3, 4, 5, 6 components. Only 6 components and I don't know, like under 20 lines of code to do what you will do with a lot of components and maybe a cluster or things like that. So now we have our information formatted. You see X and Y coordinates. The last thing that we're going to do, we're going to use just a typical list item to have the 2 elements of this list, and we'll create a vector. We're going to do this in X and XC plane. So if we go here, you see that it's, if I lift my hands, it's backwards, the prediction. So we need to perform one more thing again. What we can do, because we are doing this in the X and Z plane, we can just say, we can go to transform, we can use the mirror transform here. This will ask the geometry that we want to mirror, and we will use the X and Y plane. We will turn off the preview, and now if I lift my hands, basically you see it's recognizing basically the points that are here are my legs because I'm sitting. It cannot recognize. I'm lifting my left hand, now my right hand. So it works. Now we're getting data and actually doing something with this data inside Rhino. So I will leave it to you how to work with this to create the lines. So as you can see that it's like you can do, this is the purpose of using actually scripting inside Grasshopper. You can do things like in a cleaner way, and I wanted to show you this in this specific tutorial. Now to make your connections, you can use like a point list, and let's add a slider so you can identify let's flatten this. Let's do more precision. You can scale, of course, these vectors. So let's say I want to create the lines for the for my arm that I'm lifting now. I need to connect index 5, 7, and 9. So if I go to list item, I can create many inputs, and I can have all the points at the same time. I have a total of 17. There we are. So we can do, for example, a merge component, and I said that 5, 7, and 9. So I can connect 5, 7, 9, and just create a polyline. Let's go to curve, polyline. It should give me something. I need to, of course, flatten this. Oop. What did I do? Oh, I have to flatten this, of course. There you go. So you see, I have one of my arms. Now, do I want to create the other arm? The other arm is, I cannot see, the numbers are too small. 6, 8, and 10. So let's connect 6, 8, and 10 in that order. So now, hello. Let me put grasshopper here. Let's put runway here. And with this view, you see, it's actually getting the information, and I'm saying goodbye. Thank you for watching this. Don't forget to hit on the subscribe button. I will upload more tutorials. You can complete the skeleton to actually do this, and you can use this to, I don't know, think about the possibilities are endless. If you're really proficient in Grasshopper, you can connect this to Firefly to control an Arduino. You can, I don't know, you think about it, control, I don't know, like a facade or things like that. Facade that you prepare in Grasshopper. So thank you very much, and see you on the next tutorial series.